All right, let's talk about the inverse cosine function. So here's your graph for the cosine function, which you are very familiar with. Would you consider this function to be one-to-one? And how you would figure that out is you would look and see, we know it's a function because it passes the vertical line test. And to be one-to-one, it also has to pass the horizontal line test. Well, we see here alone that it would not be one-to-one because those inputs are producing the same outputs, so no. So once again, we have to restrict our domain so that our inverse will actually be a function. Now, it would be so convenient if we could choose the same restriction we chose for sine, negative pi over 2 to pi over 2. But we can't because in that restriction, in that little piece, this is still not one-to-one. So I can't choose that. So that is why mathematicians chose for your domain from 0 all the way to pi. Because that way we're going to hit every single one of our outputs that we need to hit because it's periodic. So from that point on, it just starts to repeat itself. So our interval for our inverse cosine is from 0 to pi. All right. So instead of us having to come up with the graph, which I'm grateful for, I just gave it to us. So this is, let's go ahead. This purple graph is our cosine part that we can only look at. And then what we did is, just to refresh our memory, how we can come up with the graph for the inverse cosine function is, well, we have this coordinate 0, 1, we swap them and we become 1, 0, so it becomes that coordinate. We have this coordinate pi over 2, 0, we swap it, it becomes 0 pi over 2. This coordinate becomes pi negative 1 for cosine. We swap them and it becomes negative 1 pi. And so this green graph is our inverse function. All right, well, our domain, we already agreed, was from 0 to pi for our cosine function because we just want to look at that piece. Now, if we were talking about cosine in general, it would be negative infinity to infinity, but because we restricted it. And then our range, again, we can just look at our graph, is from negative 1 to 1. Well, the inverse, we don't even have to think about it. We should just swap our domain and ranges. But say you do want to think about it, and I hope you do. We can see here, if we're just looking at the green graph, that our domain is negative 1 to 1. And our range is 0 to pi. All right, so now let's list all of these wonderful inputs and outputs so we have something to refer to. So I'm going to pull up this unit circle here. And now, because we restricted it, we are only looking from here to here for cosine, because otherwise it's not a function for the inverse. So I'm just going to list all these angles. So we start at 0, then we go to pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, and then we hit pi. So if we want to list all of our cosine values, well, at 0, remember it's our x, it's going to be 1. At pi over 6, it's going to be our x, it's root 3 over 2. Pi over 4, root 2 over 2. Pi over 3, 1/2. Pi over 2, 0. 2 pi over 3, negative 1/2. 3 pi over 4, negative root 2 over 2. 5 pi over 6, negative root 3 over 2, and then pi produces negative 1. So when you're doing your homework, use this chart, right? So you get familiar with it while you're practicing, and then hopefully you will not need it at all by the time we get to your exam. So we're going to do just two of these. Because I'm hoping from doing the inverse sine, it's pretty straightforward. And this is just a little boring. So A is saying inverse cosine of -1/2. So another way to say that is what angle for cosine produces -1/2. So you look here, and it looks like my angle is 2 pi over 3. Our cosine, again, because they're interchangeable, of 1, okay, well, I look here, and that angle is 0. All right, so we're going to just keep going with this video. Now this one, we're going to talk about those compositions again. And this is saying we have that f of x is cosine x and g of x is its inverse. So remember we talked about when you compose, so we are going to say f composed with g. Another way to say that is f of g of x. Okay, so if I replace those things, I'm just going to do it in one step. I end up getting cosine of the inverse of x. And this thing, again, why you compose something with its inverse is so it would just spit out the input. However, we don't have any input we can choose. This is restricted. So again, order matters. So looking here, your outside function is just cosine, okay? So cosine spits out the ratio of legs, right? Adjacent over your hypotenuse. And so that is why this is where x has to be between -1 to 1. That's the only time it will spit out the input. Now, if I switch the order, again, these mean the same thing. Well, now my outside function is the inverse function. And this should spit out just the input. However, we did some restricting here. And this is where you ask yourself, okay, well, my outside function is the inverse. So I should, at the very end, this thing should be an angle. But remember, we had to restrict our domain for the inverse function from 0 to pi. So the nice thing is, for all of these, is like when it's this way, this order, there's no way you can manipulate it. It's either lives in here or it doesn't, and it would be undefined if it doesn't. This order, when your inverse function is on the outside, this thing is always going to be an angle. You can always manipulate an angle. All right. And hopefully with these examples, what I just said will make a little bit more sense. All right. So another thing I really liked a student did, like I showed you with inverse sine, inverse cosine lives here. So these are the only two quadrants you can go between 0 to pi. Okay, so pi over 2. So again, all of these would be so easy. We could just go out and be like, oh, yep, a equals pi over 2, b equals -0.3, c equals -5 pi over 3, d equals s, blah, blah. But again, we have to make sure that it's living where it can live. So does pi over 2 live within 0 to pi? Within here? Yep, pi over 2 is here. So I didn't go into any quadrant I couldn't go into. Yep, it's fine. It's within my domain restriction, so it's just pi over 2. Now for B, it's a different order. It's saying cosine composed with inverse cosine of -0.3. So does -0.3 live within -1 to 1? It sure does. So these are really friendly to us, and it just equals -0.3. Now here come the interesting ones. So let me go ahead and pull up that unit circle. And let's get rid of this. I'm going to put this here. Okay. So just again, inverse cosine can only live here. Now, negative 5 pi over 3. Let me get a different thing. 5 pi over 3 is here. And we talked about this in a previous section. You know, to get to 5 pi over 3, you go here all the way, all the way, all the way, all the way here. But I need to go the negative direction, and I need to make just this big of an angle. So I start here, and I go, 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 and I end right here. This is where negative 5 pi over 3 would live. The problem is with negative 5 pi over 3, we only can list angles between 0 and pi. And I'm going to say it again until it's probably pretty annoying, because then it's not it's not a function if I list anything outside of that. Now, I can't say that's negative 5 pi over 3, but I could represent, now cosine there produces 1/2. I could say a different angle that would still give me the same exact answer. So instead of saying negative 5 pi over 3, I could say, well, what about just saying it as pi over 3? It puts me in the same spot. It will give me the same value. I'm just manipulating it so it fits within the restriction. All right. So now for these ones, these are fun. When you look at 5 pi over 7, so let me read this, inverse cosine of 5 pi over 7. I have to figure out first, is this between 0 and pi? And this is on you all to get better with fractions, okay? Realize from here to here is 0 to pi. If I was going to write pi with a denominator of 7, that would be 7 pi over 7, right? Well, isn't 5 pi over 7 smaller than 7 pi over 7? It is. It's probably going to live about right here. And so I would, or maybe I'm wrong actually on that. I'm definitely wrong. It would be a little bit closer to the halfway mark. Wouldn't it be right there? Because, well, I don't know where it would be, to be honest with you. It would be somewhere around here. So it lives within the restriction. And so that's why I can just say 5 pi over 7. Now let's see where, and let me just actually do a little work. Yeah, that's about right. Just to make sure. Okay, no. So 5 pi over 7, just to give us a good idea, is like kind of like right here, somewhere around there. Ish. Okay, now to do E, now I want to do inverse cosine composed with cosine of negative 5 pi over 7. So to get to positive 5 pi over 7, I did this business. And that's totally an estimate. You don't need to know exactly where it lives. But to do negative, I have to go from here to, I'm doing the same distance. So again, I'm totally approximating somewhere here. I have no idea. Okay, so just be careful with this. I don't know what this thing produces. I do know that I'm in a quadrant I can't be in, right? Like I need to only be in the first or second quadrant. So I have some problems. Now, this is where it gets a little bit tricky, and it will get better with time, I promise, is you want to think about, there's an easier way, which I'll talk about after we get there. Of course, do the hard way first, then give you the easy way if you understand it. So what happens here is you want to think about your reference angle. So if I'm at negative 5 pi over 7, I'm in a quadrant I can't be in. But this reference angle would really, really, really help me. And we've played with reference angles for a bit. If this is 5 pi over 7 negative, Remember, your reference angle has to be between 0 and pi over 2. Well, if I'm going to connect it to pi, you could either, remember, just think about it, you're completing half that revolution. So you would need another 2 pi over 7 to get to a full pi. So that's your reference angle. Now here, when you're where the blue is, when you're in that third quadrant, your cosines are producing negatives, whatever they are. I can't say it's 2 pi over 7 because that would put me here and all my cosines are positive there. So I know I need to be in this second quadrant for it to produce the same thing. So what you do, and I'm going to keep talking about this because I know it can be a little, definitely not even more than a little confusing. I do my reference angle from here to here. And what I list is this angle. So what happens is that angle, if I just go from here to here is 2 pi over 7, I'm just lifting from my reference angle. That means that this angle from here to here is just 5 pi over 7. It's definitely funky and it's going to get better the more problems we do. So the easy way is that cosine's an even function. So when your input's negative, it won't affect your output. That's the easy way, but that's only for a cosine function. So we need to know this reference angle concept for other things. So let me just try to do a little bit of a better job explaining that with something you know. So I'm going to get rid of this stuff. Okay. So if I were to say inverse cosine of let's just do negative pi over 6. Okay, well, negative pi over 6 is here. My cosine is root 3 over 2. I'm in a quadrant I cannot live in. So your reference angle there, right? Remember, that's that angle from the x-axis, either positive or negative. That angle is just pi over 6, right? We just did a negative, so we just went down, or we went clockwise instead of counterclockwise. So my reference angle is just pi over 6, so then I'm going to go from here up, and what do you know? It produces the same thing. So my answer for this one would be pi over 6. I'm going to just do one more, and then I should stop this video because it's getting too long, I know. Okay, so looking here, say I said, I'm going to add one more, cosine, inverse cosine, composed with cosine of, let's do 5 pi over 4. All right, so if you go here, 5 pi over 4, here is your angle. I'm in a quadrant I can't live in. But I can, this is the nice thing versus E, this thing didn't exist. I mean, it does exist, but it's not a nice, perfect answer. So I use that reference angle. So I'm going to use that reference angle again, just so you can convince you of why it works. So I'm somewhere I can't be, but I know my cosine produces negative root 2 over 2. So that's why this one's easier. Well, life would be good. I would just find where it can be negative root 2. And so I'd be like, oh my gosh, great. It's just 3 pi over 4. That's way easier. But also what you're doing there is, we're just looking at the unit circle, but what is happening is your reference angle from here to here is pi over 4. Okay, because this is a complete pi, so that's 4 pi over 4. If I get to 5 pi over 4, I just did an additional quarter. Well, my reference angle is pi over 4. You have options. You either go this way to pi over 4, or let me choose a different color. Oh, not that color. You either go this way to pi over 4, or your option is to go this way. Because remember, your reference angle is always from the x-axis. How you decide is, well, 5 pi over 4 produced a negative value. I also want to get out the same value, so that's why I knew to go from here to here. And that's when you list Oh, sorry, I keep choosing the same color. The angle from here all the way to here. We're gonna do a lot more.